First question is the component of weight parallel to the surface. So what I've done is I've chosen my coordinate system so that one of the axes is in the direction that I'm looking for. So X is parallel to the surface. So then that means that the Y will be perpendicular to the surface. Okay, so what we've got is we're concentrating on weight. So if you look at weight here, okay, it can be split into a component. One part of that component is parallel to the surface. So with respect to this coordinate system is in the X, and then one component is perpendicular to the surface, which is in line with the Y. Okay, so what it asks for is parallel, so that's in line with the X. And as we know that this is theta. If that's angle theta, this angle here is theta. So therefore, this component is this section of that triangle, which is W sine theta. Okay, so W sine theta is the component of the weight. So I'm concentrating on this. I'm not concerned with that there because the question is asking about the component of weight parallel to the surface. Okay, so that's W sine theta. If this question changed to the component of weight perpendicular to the surface, that would equal W cos theta because that component is perpendicular to the surface. Okay, the next question is the component of R parallel to the inclined surface. So there's a couple of ways of looking at this. So the reaction force R is always perpendicular to the surface. Okay, so the surface is always going to push back on the object in the 90 degrees to that surface. So R is always 90 degrees to the surface. Now, if we look again at the parallel part, which is in this direction here, okay, which is the X direction, and then that means that R is primarily all along the Y direction. Okay, so if you have all of the reaction force perpendicular to the surface, then none of that reaction force is acting in the horizontal direction. Okay, so that's why there's no component of reaction in the direction of the incline. Okay, so that's parallel to the surface. So if you looked at perpendicular to the surface, then this question does not concern the weight. So we do not look at the weight at all. The previous part was for the weight, okay? But R is primarily all in the direction which is perpendicular to the surface, and none of the direction of R, so none of the force R is in the horizontal direction. It's if you look at it, that will be R, and then that there is, you can think cos or whatever, but you can't get a triangle out of that because it's all in that direction. If it was slightly shifted to the right, then sure, you can split it into a component which is in the parallel and horizontal, but it's not. So therefore, all of it in the perpendicular and none in the parallel.